You're looking at an Opto22 Snap LCSX Plus controller, Snap E3000 brain board and I/O. Over here we have a DC motor operating a Gamu C67 Teflon diaphragm valve. Flow is being measured by an NT 4400 pressure and flow transducer. And we have a QSI panel mountable terminal, and you can see on the display there that the flow is reading at 101 cc's per minute with a set point of 100 and a pressure at 38.3 psi. We can, on this panel, change the set point and now we've changed the set point to 150, and you can see that it's controlling to that. Over here we have a computer display representing the flow and the pressure and the set point. The pressure is in red and the set point is in yellow, flow is in green. There's a picture of a Gamu valve on there with the NT 4400. You also have the ability here to change set point. Set point is limited between 10 and 250 at the moment. Try to put in some other value, it simply won't take it. We'll put in 100 again, and you can see that the valve closed and opened a little bit there, a little overshoot, trying to recover a little bit. And it's real close in its percentage to the actual set point. And you can see the presentation on the screen gives the exact amount. It's at flow right now saying it's at hovering around 91 with a set point of 100, pressure at 38.4. On the panel over here, if we try to set it for some value outside of that 10 to 250 range, what we get is an alarm. It says set point input is outside of limits, please enter a value between 10 and 250. If we enter over, then it won't take it. We try to go ahead and put in 150, let's say, goes ahead and takes it, goes to set point, and you can see it's controlling. We also have a low pressure alarm on the system, and what happens is as soon as the pressure is too low for whatever reason, we can try to limit flow here with this valve. We'll see if this valve will even limit our flow, and we'll go to like a maximum percentage or maximum flow. Flow pressure dropped to 22. That valve's leaking pretty bad, so it really didn't drop us that much. What I was hoping for was to get it to drop. Let's open the valve manually. Now we have an indication that the pressure is too low on there, and we have an indication that the pressure is too low right there. And you can see by the red line what pressure did. Of course our flow went way up because I opened the valve manually way up. Let's go ahead and close it. Of course the system recovered. Right now what we have though is a little light. That light indicator right there is telling us, and there is an output for a light bulb I don't have connected, but it's telling us that you need to go ahead and hit start again. Start, that light goes out and we're back in control. Of course, since you're right at set point, it's not going to try to produce any output for the valve. Change the set point to 100, there we are. And of course you get to see what it does here. This strip chart recording has the ability to be logged on the file, can be printed, have a lot of data collection capability there. There's a lot of data collection capability on any of the points. For the moment, all we're really trying to demonstrate is the fact that we do have a good control of our pressure. or I mean of our flow. There's a set point change to 25. There's the response of it. Here, let's change our set point up here. We'll change it, let's change it to 150. You can see our pressure swung quite a bit there because I've got this valve. Even though this valve is closed, it's not, it's bypassing pretty bad. I opened it up and you saw a little bit of a jump in the flow because of it, but it corrected, closed the valve. Set point change to 100 from 150. And that's the machine. The flow chart that operates all this to where you can actually change the parameters is this flow chart right here. All of the parameters that operate this control system are on this screen. There's some variables, string variables to communicate with, and so on. Here's the block for setting up the motor rate at which it opens and closes given a set point deviation, and this algorithm, this right here, this set of instructions actually is where you would want to tweak it a little bit, where you can tune the amount of error and then how fast you really want to try to open and close the valve based on the error to keep from getting overshoot or reduce overshoot as much as possible, yet still getting a reasonable response time. And just doing a little bit more to try to demonstrate the response of the flow control. What we're going to do is go to the screen here, just change set point a few times. Right now it's at 100. There's 150. There's 200. There's 50. $200 again. Once the range of set points is known, all of those points can be tweaked to hit those every time. If you try to hit a very wide number, then some of what you see is what you're going to get. So what you have to do is try to learn the application and then tweak the variables as I was showing earlier in the control to make it match what your needs are. Communications to this can be lost. You can actually lose communication by disconnecting here. The whole thing can run standalone. It runs on its own. You can still change set points here. Still run it. Runs just fine. This communication, of course, has been lost at the computer, in which that's what the alarm was for announced. Of course, it's not getting the data. If we go and hook it back up again, though, it'll go ahead and start reconnecting and resuming the collection of the data. As you can see, it's doing right here. And that's about it.